Hello, welcome back to our channel Ace Your Learning with Divya. Students, in today's video, we'll understand about closure property. Under properties of whole numbers, there are four main properties. They are closure property, commutative property, associative property, and distributivity property. First, let us understand about closure property. What is closure property? Yes, when you are adding, subtracting, multiplying or dividing any number, the answer should be a whole number. If you are not able to get the whole number as answer, means it does not belong to closure property. First, let us understand about closure property for addition. Look at an example here. 5 plus 5 is equal to 10. When you add 5 and 5, you will get the sum as 10. What is 5? 5 is a whole number. And when you added two whole numbers, you got the sum as a whole number. Right? Look at one more example. 7 plus 8. 7 is a whole number. 8 is also a whole number. You got the sum as also a whole number. Look at one more example. 0 plus 30. 0 is also whole number. 30 is also whole number, and the result, when you added 0 plus 30, you got the sum as 30. So 30 is also a whole number. You remember? Yes, the answer should be a whole number. If you are not getting the answer as whole number, means it does not belong to closure property. Now, this addition belongs to closure property? Yes. So, sum of any two numbers is a whole number. So, whole numbers are closed under addition. We can say that whole numbers are closed under addition. Next, closure property for multiplication. Here is an example. 5 into 5. 5 is a whole number again. And the result, the product what you are getting is 25 is also a whole number. Yes. And here 7 into 8. 7 is a whole number. 8 is a whole number. And 56. The product of 7 and 8 is also a whole number. Here 0 into 30 equals 0 itself. Right? And 0 is also a whole number. So, when we multiply any two whole numbers, we are getting the result as a whole number. Yes? So, the product of any two numbers is a whole number. So, whole numbers are closed under multiplication. Next, closure property for subtraction. Look at an example here. 10 minus 5. 10 is a whole number. 5 is also a whole number. And the result, the difference of 10 and 5 is also a whole number. But when you subtract 5 minus 10, yes, you will get negative number as difference. But negative numbers are not whole numbers, right? We have already learned. So, it is not a whole number. Difference of any two numbers is not always a whole number. In first example, when the whole number we subtracted by another whole number, we got the result as whole number. But in second one, we subtracted a whole number by another whole number, but also we did not get the answer as whole number, right? So here we can say it does not come under closure property. It does not come always under closure property. So whole numbers are not closed under subtraction. Closure property for division. Here 12 divided by 4 is equal to 3. 12 is a whole number, 4 is also whole number, and the result, the quotient is also a whole number, right? Look at another example. 4 divided by 12. Yes, when we do, 4 is a whole number, 12 is also a whole number. But when we divide 4 by 12, we will get the quotient as 0.3, which is a decimal number, right? So decimal number will not come under whole number. So 4 divided by 12 is not a whole number. Therefore, quotient of any two numbers is not always a whole number. So whole numbers are not closed under division. So now we can say that whole numbers are closed under addition and also under multiplication, but not under subtraction and division. Commutative property for addition. What is commutative property? Yes, it's a helpful rule. Yes, to understand whether we can switch the order of the numbers, means rearrange the order of the numbers or not under commutative property. Look at an example here. Commutative property for addition. In addition, 5 plus 4 is also equal to 9 and 4 plus 5 is also equal to 9. Means, however, you rearrange the numbers but the answer will be the same, right? Look at one more example. 7 plus 8, which is equal to 15. Also, if you interchange the numbers as 8 plus 7, the result is 15. So, however, you interchange or rearrange the numbers and add, the answer will be same. So, we can say we can add whole numbers in any order, the result remains the same. So, whole numbers are commutative under addition. Next, let us understand commutative property for multiplication. 5 into 4 is equal to 20. 4 into 5 is also equal to 20. Correct? However, you interchange the numbers and multiply, the products remains the same. 7 into 8 is also 56. 8 into 7 is also 56. So, however, you interchange the numbers and multiply, the product remains the same. If the products remain the same, the answer remains the same, means it comes under commutative property. So, multiply any two whole numbers in any order, the products remains the same. Therefore, whole numbers are commutative under multiplication. Next, commutative property for subtraction. Here, when we subtract 5 from 10, we'll get the answer as 5. But if we subtract 10 from 5, will we get the same answer? No, it is not equal to 5. It is minus 5. We are not getting the same answer when we interchange the numbers. Yes, so it does not come under commutative property. So we can say we cannot subtract whole numbers in any order. So whole numbers are not commutative under subtraction. Look at one more property for division. 12 divided by 4 is equal to 3. Now, what if we interchange? What is 4 divided by 12? 4 divided by 12 is 0.3 or 3 by 10, which is not equal to 3. So, it's not a whole number also. So, when we interchange the numbers and try to divide the numbers, the result is not the same. So, it does not come under commutative property. So here we can say we cannot divide whole numbers in any order. So whole numbers are not commutative under division. So we can conclude saying commutative property applies for addition and multiplication and not for subtraction and division. Thanks for watching. Keep supporting.